Welcome. Today we're going to talk about surface area and volume of cylinders. Cylinders are everywhere. They're in your pantry, the can of soup. If you grab a Coke out of a vending machine, it's a cylinder. A lot of makeup products or cosmetics or medications come in the form of cylinders. Even a bucket you carry around at Home Depot. There are lots of parts to a cylinder. Let's go through the anatomy real quick. All cylinders have bases that are comprised of circles. And every circle has a radius. Cylinders have two bases. The bases, much like you'd find in a prism, are parallel and congruent. And then just like a prism, your cylinder has a height. That is the distance between the two bases. If you unroll the label to a can of soup, then you'll find that the lateral area is comprised of the circumference of the circle. It has to be big enough to wrap around the can, the height. And your lateral area is always going to be a rectangle. Okay, the formulas are pretty easy to see. This is what I was just saying, that the little area is always a rectangle. And we know how to find the area of a rectangle. That's just the length times the width. Well, here's perhaps the length or the width. And if you think about it, 2 pi r, that's the circumference of the circle, and that gives you the width of the rectangle. For total surface area, we take the lateral surface area that we've already calculated and add in the top and the bottom base. Again, if you recognize, here's the formula for area of a circle, and we need 2 of them because we have a top and a bottom. Volume is exactly like the formula for prisms. It's the area of the base times the height. In this case, area of the base is going to be that pi r squared. Let's do an example. Number 1 and number 2 are similar. In example number 1, you're given the radius of the circle and the height of the cylinder, so it's not very interesting. I like example 2 because it requires us to do a little bit more thinking. To solve this problem, to find the lateral area, total area, and volume, I need to know the height of my cylinder. I need to know the radius. And I'm going to use those to calculate the area of the base. The first thing I notice is that it does not give me the radius of my circle. Instead, it gives me a right triangle drawn on top of the base. If I could draw it down here as well, it would look something like this, not drawn to scale. It gives me the hypotenuse of the right triangle. So I went ahead and drew that triangle over here. To find the radius of my cylinder, I recognize that this must be an isosceles right triangle. It has to be because the radii of a circle are always the same. And it told me what the hypotenuse of this 45-45 right triangle is. If I do the quick calculations for this right triangle, I would do so by saying square root x square root 2, because I know that's the relationship of the hypotenuse to the 2 legs, is equal to 4. And then when I solve for x, or the radius, and I simplify my expression, I end up with a radius. I'm going to put that here so that we see it. The radius is equal to 2 square root 2. If you're confused about how to simplify this radical, go back to your Unit 7 notes. I'm sure you have lots of information there. Okay, so now I know my radius, and I know the height of my cylinder. My height was 4 centimeters. My radius is 2 square root 2 centimeters. I have enough information now to find the area of my base. I remember that it's pi r squared. In this case, my radius is pi 2 square root 2, and I'm going to square that. And I want to make sure that I'm being careful here and remembering that when I square a whole number, obviously 2 times 2 is 4, but when I square the radical, that gives me the square root of 4, which is whole number 2. And then again, when I simplify this, I end up with a base of 8 pi. I have enough information now to calculate my lateral area, total area, and my volume. My lateral area, if I go back to my formula, is 2 pi, the radius times my height. I always like writing my formulas. The 2 pi stays. We always leave our answers in terms of pi, unless explicitly told to do otherwise. My radius in this case is 2 square root 2, and we know the height is 4. When I simplify this lovely expression, I end up with 16 square root 2 pi centimeters as my lateral area. I can then use this conveniently to find the total area, because my total area is my lateral area, 2 pi r times h, plus 2 of my bases, because I have a top and a bottom. And we already know what the area of the base is. We said that was 8 pi. And up here we calculated the lateral area, so I can just stick that right down here, and I do not need to do this calculation a second time. And now I must simplify this expression if possible. But since this term has a radical and this one does not, then that is my complete expression to represent the total surface area, square root 2 pi plus 8 pi centimeters squared. And I was negligent and forgot to write my lateral area in my answer blank. So I'll do that now. And then the last thing we're asked to calculate is the volume. The volume is just the area of the base times the cylinder's height. We know the area of the base is 8 pi. We know the cylinder's height is 4. And when I simplify this expression, I find that the volume for this cylinder is 32 pi centimeters cubed, because volume is a 3-dimensional measurement. And that's it, folks. That's how we solve problems involving cylinders.